In order to fully understand and completely solve polynomials and finding their zeros, we need to understand a little bit about complex numbers first. So a complex number is of the form a plus bi, where a is what we call the real part of the number, and b is the imaginary part of the number. First, I just want to go through some operations with complex numbers, such as adding, subtracting, and multiplying. So whenever you add complex numbers, you are simply going to take the real parts and add those together. So 4 plus 3 is 7. And then take the imaginary parts, which would be 5i and negative 2i, and add those together, which would give you plus 3i. And your answer is going to be of the form a plus bi every time. Okay. When you subtract, again, same thing. You're going to subtract the real parts. 3 minus 4 is going to be negative 1. And 5 minus negative 2, that's 5 plus 2, that's going to be plus 7i. When you multiply complex numbers, you're just going to do essentially the FOIL process. You're going to take 3 times 4, 12. 3 times negative 2i, that's negative 6i. 5i times 4, that's going to be plus 20i. And then 5i times negative 2i is going to be negative 10i squared, right? Negative 10i squared. The reason that we get the I squared, just think about that as if it were an x. It would be the same thing. It would be x squared. So just make sure that you understand that when you multiply two terms with I, that you make that I squared. Now, in order to simplify this, we need to understand another concept, and that is that I squared is equal to negative 1. Okay? And another way of thinking about that is that the square root of negative 1 is equal to I. Okay? So if I squared is negative 1, the square root of negative 1 is I. So anytime you have an I squared, you want to think about replacing that with negative 1. So if I replaced negative 1 for I squared, then minus 10I squared becomes plus 10. So anytime you have an I squared, you want to make sure that you make that substitution and that you simplify that term. Okay, so you should never be left with an I squared in your final answer. You want to make sure you change that so that we get plus 10 instead of minus 10I squared. Then we're going to take our real parts and combine those. So 12 and 10, that's going to be 22. And the imaginary parts, negative 6i plus 20i, that's going to be plus 14i. And again, my final answer is in the form a plus bi. That should be happening. Number 4 is a little bit different here. We're just looking at I to the 23rd power, and I want to figure out what's the best way to write this. So in order to figure that out, I'm going to go through a little bit of a pattern here with you. I to the first is just I, right, which is the square root of negative 1. So I squared, we said, was negative 1, right, because if I is the square root of negative 1, if I square that, I just get negative 1. I to the 3rd power would then be take that thing and multiply by I, which means I'm going to get negative I if I do I to the 3rd power. And I to the 4th power, if I take negative I and I multiply by another I, that's going to be negative I squared, which is going to turn that to positive 1. The next one would be I to the 5th, and I to the 5th would then say, okay, take 1 and multiply by I. Well, I'm going to be back to I. And then I'm going to continue this pattern of going between I, negative 1, negative I, and 1. So when I want to do I to a specific power, I want to think about where in this order is that number going to fall. Okay, so it goes through the complete process every 4 values of I there. So what I'm going to do is I'm going to take the number, the 23, I'm going to divide that by 4 and then look at my remainder. So if I divide that by 4, my remainder would be 3, because 20 would be a multiple of 4 and I have 3 left over, which means when I do I to the 23rd, I am going to be at this step of this process. So I to the 3rd is going to equal negative 1, so I to the 23rd also, negative I. So I to the 23rd is also negative I. Okay, when you divide complex numbers, what you want to do here is you want to look at the bottom, and you want to multiply by the conjugate of the bottom. So I'm going to multiply by 1 plus 2i on top and on bottom. 1 plus 2i. All you're going to do at that point in time is go ahead and multiply out the top. So FOIL the top, FOIL the bottom, and then things are going to cancel here. So on top, I'm going to do 3 times 1, 3 times 2i, plus 6i. 5i times 1, plus 5i. 5i times 2i is plus 10i squared. On bottom, 1 times 1, 1 times 2i, negative 2i times 1, which would be negative 2i, and negative 2i times 2i, which would be negative 4i squared. Okay, once you multiply all that out, a couple things happen here. Plus 10i squared, we're going to replace that with negative 10. Minus 4i squared, we're going to replace that with positive 4. Also on bottom, because we did the conjugate of the bottom, so the conjugate means just change that middle sign from a minus to a plus. When you do conjugates, the two middle terms will always cancel each other out. So you're not going to be left with an I on the bottom. So now I'm going to take the top, combine my real terms, so 3 and negative 10 would be negative 7. Combine the imaginary terms, 6i and 5i is 11i. On bottom, all I'm left with is 1 plus 4, which is 5. And I'm going to take this one step further because I always want my answer to be in the form a plus bi. I'm going to divide each one by 5. So negative 7/5 plus 11/5 I. Last one here, if there's only one term on bottom, you still want to multiply, but I'm going to just do the opposite of what's on bottom. So I'm going to multiply by negative 4i. On top, I get negative 28i minus 12i squared. On bottom, I get negative 16i squared. Your I squared terms, you want to change those. So negative 12i squared is just plus 12. Negative 16i squared is just plus 16. So on top, I have 12 minus 28i. On bottom, I have 16. I'm going to reduce both of these. So 12 over 16, divide those both by 4. It's going to be 3/4 minus 28 over 16. Again, I can divide those by 4, and that's going to give me 7 over 4i. And my final answer, again, is of the form a plus bi.